So let's do a couple of problems. Let's do square root of 2 times square root of 8. So write those down. All right, so how do you simplify square roots? Well, how you simplify radicals in general is you look at, whenever you see like square root of something times square root of something, this is really one big square root. So you can write this down as square root of 16, which we all know is 4, right? See, not too bad, right? Like when you see radicals, like writing it as one big radical is usually a very good thing. So your turn. So if I give you the cubed root of -5 times the cubed root of 25, what do you get? So make it one big radical. Yes?
Cube root of -125.
Well, what's the final answer?
5.
Well, actually -5. Right? Because if you make this one big cubed root, you get cubed root of -125, right? And what's the cubed root of, are we okay, the cubed root of 125 is 5? Does the negative live or die?
Live.
Well, live, because it's an odd root, and so this gives us -5. Does that make sense? So when dealing with like radicals, either square root or cube root, fourth root, fifth root, whatever, right? Anytime you see a bunch of them multiplied together, right? 95% of the time, your job is make it one big radical and then simplify, right? Okay. Well, let's talk about let's look at questions 3 and 4. So 3, let's see, that's the square root of 72x cubed. And we've done this, right? How do you deal with numbers and letters, right? Well, how do you deal with numbers? Well, the way you deal with numbers and letters is deal with the letter first, right? And this is what we talked about on Tuesday, right? I've got an x cubed. How many x's get to come out? 1, right? Because there's a 2 here, right? How many times does 2 go into 3? 1, so there's an x. Because when we're done, we're going to have something outside the square root, something inside the square root. How many x's are left inside? Okay, we got a 1 because 2 goes into 3 one time with a remainder of 1, right? And now you got the number, right? And how do you deal with the number? Well, your job when you're dealing with square roots is you want to break it into something I know the square root of and whatever's left over, right? And what do I know the square root of that goes into 72?
36.
Well, you want the biggest number.
36.
I heard you.
Oh.
Okay. All right. 9 does work, but you want to pick the biggest number. And so this is, you think of this as 36 and 2, right? And so when you take the square root of each of those, right, we get our square root of 36, which gives us 6. And what's left inside? Your 2. All right, well, but this is stuff we've done, right? We've kind of done that. All right, what about cubed roots? What if I give you the cubed root of 80 into the 5th? I mean, so we dealt with square roots. Well, how do you deal with cube roots? Well, be honest, it's the same way. You deal with the letters first and then the numbers. So our final answer is going to have cubed root, and we're trying to figure out, what's outside and what's inside. And my suggestion is always deal with the letters first. Okay? Are there going to be ends on the outside? How many ends on the outside? 1. So I get 1 end on the outside. How many ends left on the inside? 2. We talked about that on Tuesday, right? Like, how many times does it go in here? It goes into it once. What's the remainder? 2. So that gives me n squared. So far, so good? All right, so we've handled the letters. Now we have to handle the number, right? How do you handle cubed roots? Well, just like square roots, we've got to figure out, what's the perfect square. When you're dealing with cube roots, you have to know, well, what's your perfect cubes. At that point, you got to know perfect cubes. That's the bad news. The good news is you don't have to know much. I mean, you've got to know, 8, 27, 64, and 125. That gets pretty much everything you need, right? So, which perfect cube goes into 80? Is it obvious it's 8? And so when we look at that, we think of this as, think of that 80 as 8 times 10. All right? And then think of, okay, I've got the cube root of this and the cube root of this. What number comes on the outside? 2. What's left inside? 10. Does that make sense? Right? I think that's what I tried to teach that Tuesday, but I also tried to teach a whole lot of extra stuff. And so, that may have gotten diluted. Okay. So now let's put those two ideas together. Okay. Or here, let's look at 5. Let's say I give you the cubed root of 54x squared y cubed times the cubed root of 5. Yeah, I'll give you a little time to write that down. Right? So what do you do when you're multiplying, two cube roots together, right? Just like before, right? Cubed root of something times cubed root of something is cubed root of a big thing, right? We just multiply it together. And this is one of those things that 99% of the time, the best thing to do is make it one big cube root. There are some cases where you break it up, but they're very specialized. Just in general, whenever you're given some radical times some radical, as long as it's the same, right? If this is cubed root and this is square.
5 to the 4th or 54?
54. Right. Yeah, if it's like square root and cubed root, you can't just make it one big thing. I mean, you can, but it's a royal pain, and that's not what I'm after today. Right? Now, I want to talk about how we multiply this together. Right? So my goal is to make this one big cubed root. Right? You could. Right? First, let's deal with the letters. And I'll deal with the numbers in just a second. Because letters are always easier whenever you're trying to simplify radicals. How many total x's do we have? Are we okay with x to the 5th? And so this gives us x to the 5th. How many total y's do we have? 7. That was easy, wasn't it? All right? It was very easy dealing with the letters. Now, and even from here, you could probably figure out what's going to go out and what's going to stay in, right? So the letters, that's not the issue. The thing I'm really interested in is the numbers. Because you could say 54 times 5 and put whatever that number is here, right? But I'm going to advise against it. And here's why. Sometimes you get lucky and you multiply it together and it becomes something that you can easily see to split up. Most of the time, what happens when you take a number and you multiply it times another number is you get a really big number. And if you're trying to simplify cubed roots, 4th roots, 5th roots, having a really big number doesn't help you out a whole lot. Because it typically makes it harder to figure out the perfect, what comes out. Does that make sense? So when given an option of multiplying numbers together, don't, right? Right? So what do? Right? Well, what you do is, instead of just making one big number, we could say that this is 54 times 5. Having it in this form, my claim is having it look like this is easier than having the big number 90% of the time. Now we do what we did before. Let's break this up. So I'm going to have stuff inside and stuff outside. Let's deal with the letters first. All right, how many x's are going to be on the outside? 1. Easy, right? 3 goes into 5 one time, I have an x on the outside. How many x's are left inside? 2. So I have an x squared. How many y's are on the outside? 2. Because 3 goes into 2 times, so I get y squared. How many y's are left on the inside? 1. If you had these switched where it was y squared and x, it doesn't matter. I'm writing it, typically when you have variables all grouped together, they put them in alphabetical order. It doesn't mean that's what you have to do. Alex would give you credit either way, right? Now, are we okay with the letters? Now let's deal with the numbers. Let's deal with the number. All right, is there a cube root of 5? No. 54, I don't know. Is there a perfect cube that goes into 54? What? 27. Are we okay with that? And so when I look at this, I look at that 54 and I see, okay, this is 27 times 2 times 5. Right? There's the 27 times 2 and I have a 5. Right? And so now, you know, what number do I know comes out? Everybody see we got the cube root of 27? Which is going to give me a 3. All right, what's left inside? A 10. Because you have a 2 and a 5. Everybody see we got a 10 left inside? Does that make sense? All right. So, you try. What if I give you 3 square root of 7x cubed times 2 square root of 21x cubed y squared?
Is it 21x cubed?
Yes. All right. Everybody got an answer? Are we worried about the numbers or the letters? Were the letters easy? All right. All right, so let's talk about the numbers. All right, let's cover our game plan here. First, what do you do with the 3 and the 2? Multiply them. It's outside, right? In general, whenever you have these radicals, stuff outside the radicals play together, stuff inside play together, right? They don't go, right? So this is going to multiply. That's going to give me a 6. I'm going to have a square root of something. I'll worry about the numbers later. Let's deal with the letters. How many x's do we have? 6. How many y's do we have? 2. So far, so good? Now, as far as the number goes, I really don't want to multiply 7 times 21. Right? My claim is that's not going to be a very helpful number. And since I don't want to do that, I'm going to go ahead and say 7 times 21. Right? Well, now this is starting to look something like over here, right? So let's deal with our variables. I know my final answer is going to have a square root. I've got some stuff inside. I've got some stuff outside. Let's talk about the letters. How many x's come out? 3. How many y's come out? 1. Are there any x's or y's left in here? No. All right? So 2 goes into 2 one time?
It's not, oh, it isn't. Sorry. Wait, does the 6?
Oh, it's still here. Yeah. The 6 is still here, right? It's still decoration, it's still here. But now, let's talk about that 7 times 21. Right? And let's talk about the significance of not multiplying it out, right? I mean, what's it mean? Seeing 147 doesn't help me, right? But when I see 7 times 21, all right, I see a 7, and then I look at that 21, and if I were going to break 21 up, what would I say 21 is?
7 and 3.
Are we okay that 21 is 7 times 3? Is that easy to see? I mean, I think it's pretty easy to see when you see the 21. Maybe not so much at the 147. And so if I break this up as 7 times 3, well, that's interesting. See, 7 times 7 is what?
49.
Could I take the square root of 49?
Yes.
Can y'all see that? Like when I multiply this, I've got 2 7s, and when I get 2 7s, that gives me a 49, and the square root of 49 is 7. So what number comes out here? A 7. What's left inside?
3.
The 3. Did you see how that worked? Well, now to finish this up, okay, this is going to give me 42 x cubed y, and I get the square root of 3. Yes?
So you're the
Mm-hmm. Does that make sense? Okay. All right. Again, I think I tried to do this Tuesday, but I tried to do it way, way, way too fast. Does it make a little more sense now? All right. So we talked about multiplying. Guess what's next? Dividing, right? Yes, you know. So when you're multiplying with radicals, the main idea is, all right, make it one big radical, right? Put everything together, but don't multiply the numbers, right? Because I think that makes it harder to figure out what goes out. And then start pulling letters out. All right, next. Well, what about dividing? No. So what if I give you the cubed root of 32 over the cubed root of negative 4? What do you do? What do you do when you divide? Kind of the same thing when you multiply. Like if you see like radical times radical, I said make it one big radical. Well, anytime you see like radical divided by radical, make it one big radical. You can make this like one giant radical. So this ends up being the cubed root of 32 over negative 4. Well, what's 32 over negative 4?
Negative.
Okay, can we simplify that? When I simplify that, that's going to give me this cubed root of negative 8. Oh, well, that's convenient. What's our cubed root of negative 8?
Negative 2.
Okay, we got a negative 2 out of that. Okay. So your turn, but I'm going to put some x's in it. What if I give you the cubed root of 162x to the 5th over the cubed root of 3x squared?
Is that X in the
Yes, that was all in the, sorry about that, a little sloppy. So, cubed root over cubed root, make one giant cubed root. If I make one giant cubed root, let's see. Actually, let's just sort of talk about it. We can sort of visualize it's one big root. Are there more x's on top or bottom? How many more on top? 3. So I get an x cubed. How many times does 3 go into 162? 54. Right, so I end up with 54. And so this all simplifies to the cube root of 54x cubed, right? Well, now let's deal with this. How many x's come out? 1. And then I end up with x, and then there's the cube root. Any x's left inside? How do we break up the 54? Yeah. So we break up that number, that 54 is 27 times 2. What's the cube root of 27? 3. What's left inside? 2. Did that make sense? More importantly, does this feel a little more comfortable now than it did Tuesday? All right. Now, that's nice. When you see fractions, your first instinct is, can I make it combine it, right? And in these two cases, in these two examples, when you combine it, it works out real nice, doesn't it? But it doesn't always work out nice, right? In fact, most of the time it doesn't, right? So what do you do when it doesn't work out? Like, what do you do if, oh wait, here. Yeah. Like, what happens if I give you square root of 2 over square root of 3? Is there any way that that's going to simplify? No. All right. Yeah. It's obvious that's not going to simplify, right? So what do? Well, did you have did you have a teacher that says you can't have a square in the bottom? Okay. If I've got time at the end of the period, I'm going to talk about, well, that's not necessarily true. Right? I just remember when I was in school going through, I remember hearing there were certain rules like you can't divide by 0 and you can't have a square root in the bottom. Well, you can't divide by 0, right? That's bad. Technically, there's nothing wrong with having a square root in the bottom. There is a reason we get rid of it, and that reason has something to do with before we had calculators. And so if I have time, I'll talk about that. But for the most part, technically, it's okay to have a square. It's not like you've done anything wrong mathematically. But for the purpose of this course, yeah, I want to get rid of the square root in the bottom, right? And it's got an official name. It's called rationalizing the denominator. All that is, make the denominator nice. Make the denominator without a fraction. Make the denominator without a square root. So what do? Right? I need to get rid of I've got to get rid of the square root. I can't get rid of the number, but I can get rid of the square root. And a lot of this, when you're dealing with square roots, we have this, I don't know, I think I did this rule last semester. I talked about square root of happy face times square root of happy face gives me a happy face. Did I put that on the board last semester? So the way you get rid of a square root is basically multiply by the same thing, right? So if I want to get rid of the square root of the 3, what do I need to multiply top and bottom by? I'm going to multiply top and bottom by square root of 3. And what square root of 3 times square root of 3 give me? 3. And remember, this we multiply, we can make it one big square root, so that gives me the square root of 6. Is that part okay? All right. Well, what if it was cube root of 2 over cube root of 3? What do? All right? Like, how do you get rid of the radical when it's a cubed root? Right? Like with a square root, we multiply it by the same thing, and notice that square root of, technically, here's what happened. Technically, square root of 3 times square root of 3 was square root of 9, which gives us a 3. That's what happened, right? What do I need to multiply the bottom by that so I can get rid of my cubed root of 3? Oh, I like that. I don't know if anybody heard that, but Adam said, no, sorry, I gave your last name. But he said multiply by 2 of these, right? I think what's going on in your head is you know the cubed root of 3 cubed gives you 3, right? Because if this is something to the 3rd power, I know this cancels. What could I multiply this by so I get 3 to the 3rd power? How many 3's do I currently have?
1,
How many more do I need?
2.
2. So I'm going to multiply by 3 squared. And then whatever I do to the bottom, I have to do to the top. Does that make sense? And I think I did a terrible job of picking cubed root of 3. I should have done flipped it around where it's cubed root of 2 so I didn't have so many 3's. But do you see the idea where if I've got cubed root, I need 3 of whatever? And so now when I look at this, this is going to give me, what do I get at the bottom? Do you see at the bottom I get a 3? Because this gives me the cubed root of 3 cubed. So that gives me a 3. What do I get on top? Cubed root of what? Well, what's that? 18. That's 9, right? Times 2, which is going to give me 18. That kind of makes sense. All right. Well, what if I ask, what about the cubed root of 5 over, let's see, 2x squared? So I start, when I look at this, all right, first, I instantly think this is, I know anytime I see a giant fraction, I can break it apart. So I can say this is going to be cubed root of 5 over the cubed root of 2x squared. And our job is, I want to get rid of the cubed root. And so I'm going to have to multiply by the cubed root of something on the bottom. What goes here so I get rid of my cubed root? What number has to go here? Or 4, right? Does everybody see we've got to have a 4? Because I get my 4 times the 2 gives me the 8, and I know the cubed root of 8. How many x's do I need?
1.
Do you see I need 1 more x? If I want to get rid of, can we agree that the cubed root of x cubed gives me x? So if I've got 3 x's in here, right, then the cubed root goes away. How many x's do I have? 2. How many more do I need? I need 1 more x. And whatever you do to the bottom, you have to do to the top, so that's going to give me cubed root of 4x. So now what do we have on the bottom?
2x.
Do you see we have a 2x on the bottom? If you don't see that, just imagine. What happens if you multiply these together? Actually, once you kind of go through the process of multiplying this together, if you multiply these together, this is going to give me the cubed root of 8x cubed, isn't it? 2 times 4 is 8, right? And if I take the cubed root of each of those, what are we going to get? 2x. And so I get a 2x on the bottom. And now what's on top? Cubed root of 20x. And please don't have the urge to try to cancel stuff out. That would be really bad, right? This is inside the radical. This is outside the radical. They don't play together. When I taught Algebra 1, I always talk about that. This is inside the house, this is outside the house, they're separated. You can't do anything with those. Did that kind of make sense? All right. So try this one. Let's say I give you the cube root of 4 over the cube root of 6x. I think I'm being a little repetitive here. Simplify this one. Yeah. Anytime you see fractions, you always want to reduce. That's why they've been talking about reducing fractions forever, right? Because anytime you can make the number smaller, your life is easier. So the first thing you're going to do is look at this and say, oh, this is really just the cube root of 2 over the cube root of 3x. And now you look at it and you think, well, what do I need? What do I need here? Does anyone need a 9x squared? Like to get this to be a cube, I need a 9. To get this to be a cube, I need an x squared. And do the same thing top and bottom. And so on top, I end up with the cube root of 18x squared. And on the bottom, a 3x. Does that make sense?
How did you get the... Why would it be 3x at the bottom and not 6x?
When you multiply these together, you're going to get cube root of 27x cubed, right? Three times 9 is 27 x cubed.
Wait, I mean, from the original problem, the bottom was 6x, right?
Yes.
So how did you get 3?
I reduced. Think of the,
Okay.
yeah. Anytime you can reduce, it makes your life a lot easier. All right, last example. So what if I ask for the 5th root, rationalize the denominator here, the 5th root of 3 over actually, let's do x to the 4th x, y to the 5th over y squared. How would you simplify this? Break it apart. Actually, first, could you simplify anything? Could you cancel stuff? Always do that. Go ahead and finish. Okay, so when we clean this up, I can say this is the 5th root. We got a 3 up here and a y cubed over the 5th root of 4x cubed. Okay. And now your job is, how do you rationalize your denominator, right? So we're going to multiply by the 5th root. Let's deal with the letters first. How many more x's do we need? Are we okay that we need 2 more x's to get 5? So I need x squared. But then it's like, how do we deal with this, right? Now, my challenge, the way I want you to think about this is, could you think of that 4 as a 2 squared? And if that's a 2 squared, what needs to go here? Do you see we need a 2 cubed to get 5 total? 2? So that gives us 2 cubed here, and then I multiply that top and bottom. Does that make sense? And then your final answer is going to be a 2x in the bottom, and then on top, 8 times 3 is 24, x squared, y cubed, 5th root.